Hello everyone, here are the answers to the 4 problems I assigned off of GIF 7.3, all in cubic units, so please take a look at them. You can retry the problems to see if you're coming up with these before you view the rest of the video to see my work and explanations. Alright, so for number 3, we are asked to find the volume of the solid generated by rotating about the x-axis, the region bounded by the graph of y equals tangent x. So you can see I already have that sketched in ahead of time. I just took it from negative pi over 2 to pi over 2. Notice that those are where the asymptotes are. But we want to keep this in between the lines x equals negative pi over 4 and then x equals pi over 4. So we could also have some vertical lines drawn in there as well. So what we're looking at is this section from negative pi over 4 to pi over 4. So if we revolve this about the x-axis, then we get a section that's also drawn like this. So it's coming, we could also just reflect the points here and here. So then we get a section that's also drawn like this. All right, so we are just going from negative pi over 4 to pi over 4 right here and here. So we are revolving these pieces right here. So just by making that sketch. So that is the section or the shape that we're getting. All right, so again, each area or each slice rather is still a circle. And then the area of each circle is going to be pi r squared. So if we look at the radius here, just of each one, we are going up again just to the y value, which would just be the tangent x. So our area, which would start off with pi r squared, is going to become pi times tangent x squared, or pi times tangent square x. Now, because we have this other side here, we're definitely going to double this. So when we go to set up our volume, the integral for volume, we're going to double it because we have this other side. Normally we're just looking at 0 to like pi over 4, but because we have the other side as well, we're going from negative pi over 4 to pi over 4. All we have to do is double this. So we could double the integral from just 0 to pi over 4 of pi. We could write this as tangent square x dx. Here we want to use an identity to help us out, but we could also put the 2 pi out in front here. And I'm going to use a Pythagorean identity. Tangent square x is equal to secant square x minus 1. A lot easier to take the antiderivative here. So we get 2 pi times, we're just going to get a tangent x minus x from 0 to pi over 4. So this will become 2 pi times tangent of pi over 4 minus pi over 4 minus tangent of 0 minus 0. So tangent of pi over 4 is just 1. So we get 2 pi times the quantity 1 minus pi over 4. Tangent of 0 is just 0. So we get 2 pi minus, we'll get pi squared over 2 cubic units. All right, looking at number 6, we are asked to find the volume generated if the region bounded by the curves described is rotated about the x-axis again, and then sketch the region to be rotated. So I already have the y equals x cubed here, just going from 0 to 2 so far, but we need to cut this off from x equals 1 to x equals 2, and then again y equals 0, so the lower bound right here. So we're looking, first I want to just reflect this. So we're looking at, and again along my y-axis I'm counting by ones here just to be able to fit in a 2 cube. So I'll reflect this over the x-axis. And again, drawing in just from 1 to 2, so we're looking at from here to the edge here. Has some pretty stretched out circular discs. So we want to go ahead and sketch these in. All right, so again, our slices are circles. Each area, which is pi r squared in this case, each radius still goes up to equal the y value here, which is x cubed. So then this becomes pi times x cubed squared, or pi x to the 6th. So then our volume is going to be the integral just from 1 to 2. We could put the pi out in front and just have x to the 6th dx. So now this becomes pi times x to the 7th over 7 from x equals 1 to x equals 2. All right, so 2 to the 7th will give us 128. I'll leave this out here. And then minus 1/7. So this is where we're getting 127 pi over 7 cubic units. It's a little bit on the nicer side is that the actual integration steps are not that long. The toughest part, the most important part, is making that sketch, trying to draw the picture as nice as possible so we can just come up with how to represent the radius, because as soon as we have the area, all we have to do is substitute that into our integral and figure out what the limits of integration are. All right, 7 again is to rotate about the x-axis, the region bounded by these curves and lines, y equals 1 over x, which is a rational function, and I have that sketched. Again, we're just stopping this from x equals 1 to x equals 2. But again, I want to start by reflecting over the x-axis here. So if I go over 1/2, the reciprocal of that would be 2. Same thing down here, even though I don't have to go that far. Reciprocal of 1 is just going to be 1, and then reciprocal of 2 will just be 1/2. And then drawing this in as well. Draw that a little better. All right, so we're just going from x equals 1 to x equals 2, drawing in our circular slices. So again, if it helps, this whole region should be shaded. I just don't want to put too much on the picture that it makes it tougher to tell what's going on. But the whole idea, I'm just going to shade in yellow, is if we were to shade this, we get this figure that looks like this. And then again, we can redraw the circles over it. And that's how we're getting our figure. All right, so again, each slice is a circle. The area, pi r squared. In this case, each radius again goes up to the y value, which is 1 over x. So then this becomes pi times 1 over x squared, which is just pi over x squared. And then our volume is going to be the integral from 1 to 2. Again, we could put the pi value out in front if it helps, and then we just get 1 over x squared dx, which we could write as pi times the integral from 1 to 2, x to the -2nd dx. So then this just becomes pi, and then this will give us x to the -1st over -1, from x equals 1 to x equals 2, or just writing this off to the side real quick, it just becomes -1 over x, from x equals 1 to x equals 2. So we're going to get pi times -1/2 minus, it'll be a -1. So we're going to get a -1/2 pi plus pi, or we just get a 1/2 pi, or pi over 2 cubic units. All right, so I hope you guys are doing okay with these so far. We've got one more to go over, and as always, let me know if you have any questions along the way. All right, so for number 9, again, we're looking at y equals x cubed, x equals 0 to y equals 1. Here we are rotating about the y-axis. So when we're looking at x equals 0, that's just the y-axis here to y equals 1. So we're just looking at this right here for y equals 1. And then to reflect this over the y-axis, I'm just looking at this curve so far. So when we go to draw in our circular slices, again, we're looking at the shaded region that's going to get rotated like this. So we almost have like the shape of a bowl as we start to spin this. All right, so again, each slice is a circle. But now the area, pi r squared, here each radius is going to be in terms of y. So if we reach out this way, we're going to get an x value. So we have to solve this as x is equal to the cube root of y, or y to the 1/3. So then this becomes pi times y to the 1/3 squared, or pi to the 2/3. Pi times y to the 2/3 rather. All right, so our volume is going to be, again, this is with respect to y, so we're going y equals 0 to y equals 1. We could put the pi value out front, and then we just get y to the 2/3 times dy. So very carefully here, 2/3 adding 3/3 will give us 5/3 over 5/3. And from 0 to 1 here, and then we could say it's 3/5 pi times y to the 5/3 from 0 to 1. So we just get 3/5 pi. 1 to the 5/3 will just give us 1, minus 0 will just give us that 0 here. So 3/5 pi cubic units is our final answer. All right, so as I just mentioned, please let me know if you have any questions. Our next lesson, we're going to be revolving about lines other than the x and y axes. So our slices no longer become circles. They're not solid. There's a hole in the middle, and we call those washers. So please take a look at the next video as well. I'm only going to give you guys 2 homework problems to try. Like I said, I'm not trying to give you too much, just enough to get a basic understanding of calculating volume here. Take care, guys.